Bismillahirrahmanirrahim. Iyaka na'budu wa iyaka nasta'in. Assalamu alaikum. Hello and hola to Vamos a Estudiar. Thank you so much for your support and your cooperation. Now we come up with another topic that is related to the chapter number 10, that is acid bases and salts, and that is all about pH scale. Now, as you know that whenever we are talking about pH, it comes from originally it was introduced by a Danish chemist Soren Sorensen in 1845 to 1939, and the basis for pH scale is the concentration of hydrogens in pure water. So when we go for the auto-ionization concept of water, it means it's a self-ionization, and as you consider water as a weak electrolyte, because it ionizes very slightly into ions, and water split itself into hydrogen ions and OH ions. Then you proceed towards the equilibrium expression, and one thing should kept in your mind that the product should taken in numerator and the reactants in denominator. So after writing the Kc expression, water is taken as a constant, so you taken it on that side where already the Kc expression is there, and you come across to two constants, Kc and water. So you are introducing a new constant, which is Kw, which is ionic product constant of water, which is the product of molar concentration of hydrogen ions and OH negative ions. So the value for this is 1 into 10 raised to the power minus 14 at 25 degrees centigrade. And as you know that it is very important to mention the temperature over here, because this Kw value is temperature dependent. And if you change the temperature, obviously the rate of dissociation of water will change. That's why it's important that you have to mention the value or at particular temperature. So this value 1 into 10 raised to the power minus 14 is particular at 25 degree centigrade. Now over here you have to consider and you have to support and you have to go for a logical term that when you suppose that one molecule of water produces the equal amount of hydrogen ions and hydroxide ions, so why not we take that H positive is equal to OH negative, and we simplify it by taking H positive 2 is equal to 1 into 10 raised to the power minus 14. So when you are taking the square root of this, you are come to know about the single value of hydrogen ion, which is 1 into 10 raised to the power minus 7. And likewise, you come across to the value of OH negative ion, which is 1 into 10 raised to the power minus 7. So after that, you are coming across to the Kw value, which is for the hydrogen, which is 1 into 10 raised to the power minus 7, and for hydroxyl ions 1 into 10 raised to the power minus 7. Over here, this slide is basically representing that Kw is dependent on temperature at different degrees. For example, at 10 degrees, the value would be 2.9 into 10 raised to the minus 15. At 25, the most commonly room temperature is 1 into 10 raised to the power minus 14. And at 37, it is 2.4 into 10 raised to the power minus 14. So why there is a need to find out the pH of hydrogen ion concentration, because you know that hydrogen ion concentration is very small with the negative exponents and it is very difficult to work with. So what we do is that we are taking the negative log of molar concentration of hydrogen ion, and P always stands for minus log. And if you're going for H, so it is minus log of hydrogen ion concentration, and the mathematical expression is given below. Likewise, if you are go for again, you are having that whole term and the whole thing in front of you, and the basic concept is that to convert the smaller value into a measurable value or in a measurable term. So over here we are having that with reference to this equation, a scale developed according to the molar concentration of hydrogen ion, that is ranging from 0 to 14. So POH, similarly, P stands for negative log, and when you go for OH ions, so it is the negative log of molar concentration of hydroxide ions, and the way of representation is small p with the capital OH is equal to minus log hydrogen ion concentration. So whenever you go for the calculations of water, you come to know that pH is equal to minus log hydrogen ion concentration. And from the data which you have solved earlier, you are taking 1 into 10 to minus 7 as log 10 is equal to 1. So it would be equal to minus 7, that is equal to positive 7. That means that minus 7 is turning into positive 7. Similarly, you go for the calculations of POH and you come across to the same answer, 7. And when you count that pH plus POH, that is equal to 14. So the derivation is coming in front of you. You can solve this derivation like that when we go for the ionic product constant of water Kw, it is the product of H positive ion and OH negative ions. You have to take the logarithm on both sides and then you have to multiply it with the minus 1. When you multiply it with the minus 1, then you have to put the values 10 raised to 1 into 10 raised to minus 7 in both the cases, and finally you come across to the value which is pH plus POH is equal to 14. So we come to the conclusion the 7 is the neutral point, and within 0 to 6 we are having the acidic range, and above 8 to 14 we are having the basic range. So 0 is highly acidic and 14 is highly basic. So when we moving from 0 towards 14, we are having the range of highly acidic, then slightly acidic, then neutral, then slightly basic, and finally it ends up to highly basic. So whenever you are expecting pH is given and you are asked to find out the POH of the solution, that simply you have to apply the formula pH plus POH is equal to 14. So pH is 0 and you have to minus 14 minus 0, the answer POH would be 14. Likewise, if pH is 1, 14 minus 1, the answer would be 13. If pH is 2, 14 minus 2, the answer for POH is 12. So similarly, go through the whole situation. In acidic solution, obviously hydrogen ion concentration should be greater than OH negative ions. In basic solution, hydrogen ion concentration should be less than OH negative ions. But for the neutral solution, H positive ions concentration should be equal to OH negative ion concentration. As far as the pH or the interpretation of pH scale is concerned, for example, you are having two solutions, pH of solution 1 and the second solution whose pH is 2. So when you compare that, how much time the solution of pH 1 is stronger than the solution which is having pH 2, so it's 10 times. But when you compare it with the solution having pH 3, so it is 100 times stronger than that of the one. And why? Because you are having that in front of you, are having the calculation that why we predict so. So likewise, we are having that conclusions that pH scale is very important because it is telling you about the final verdict that 7 is the neutral one. For the acidic solution, the pH should be less than 7. For basic solution, it should be greater than 7, and the range is lying between 0 to 14. So as far as the uses of pH is concerned, it tells you about the nature of the solution, whether it's acidic or basic or it's neutral. Secondly, in order to prepare the medicines, you always keep this in your mind that within human body, the enzymes are working at specific pH. And your blood is buffered at specific pH. The enzymes in the mouth and the enzyme in the stomach, they work at the different pH. So whenever we are trying to find out the different cosmetics or the medicines and we want to prepare a cultural mediums at biological levels, we want a specific concentration of hydrogen ions. So in order to prepare the standard solutions are those whose molarities are known. So whenever for the biological reactions or in chemistry, whenever you want some sort of standard solutions, this pH scale is very helpful for you guys. So I hope this short lesson will be helpful to make it understand that why this pH scale is important and from where actually it is originated. Till then, for the next lecture, Allah Hafiz from my side. Thank you.